Welcome. Today we're going to talk about integer exponents and exponent rules. First, before we get into any new information, I just want to review the parts of an exponent. If I have an expression like b raised to the x, this b, if we were to give it a name, that is called the base exponential expression. The x is what we call the exponent. It tells us how many times we need to multiply the base by itself. Let's look at a couple rules for integer exponents. So the first rule we're going to look at is if we have a zero exponent. If we have a zero exponent, how we would phrase this is any non-zero number raised to the power of 0 is going to equal 1. How we would write that is, say we have 2 and we raise it to the 0 power. If that happens, we just write our answer as 1. So in a more general form, what we can say is x to the 0 is equal to 1, but there is one condition to this. X itself cannot equal 0. The other type of integer exponent we're going to look at is if we have a negative exponent. In this case, a non-zero number raised to a negative exponent is equal to 1 divided by that number raised by the opposite, and in parentheses we can call it positive exponent. So how we would write that is, say we have, as an example, 3 and we raise it to the negative 2 power. What we do is we rewrite that as 1 over 3 to the positive 2 power, and then we can actually evaluate that. 3 to the positive 2 power is 3 times 3, which is 9. So 3 to the negative 2 power is going to be 1 over 9. We can generalize this by saying if x does not equal 0 and n is an integer, so a positive or a negative whole number, then x to the negative n power is going to equal 1 over x to the positive n power. So let's look at a couple examples. So we can call this example 1. We're going to simplify. We have 4 problems we're going to look at. We're going to look at 10 to the negative 4th power, we're going to look at negative 2 to the negative 4th power, negative 2 to the negative fifth power. And lastly, we'll look at 5 to the 0 power. All right, so with this first one, 10 to the negative fourth power, that's a negative exponent. So we're going to start by writing that as 1 over 10, and then we're going to make that negative 4 a positive 4. Then what we're going to do is we're going to multiply 10 by itself 4 times. So we're going to write this as 1 over 10 times 10 times 10 times 10. Well, 10 times 10 is 100. 100 times 10 is 1,000. And 1,000 times 10 is 10,000. So 10 to the negative fourth is going to be 1 over 10,000. Or I would also take 0.00001. I would take either of those. Let's look at B now. We've got negative 2 to the negative fourth power. So the first thing we're going to do is we're going to write this as 1 over negative 2 to the fourth power. Now we can expand that power out. We're going to go 1 over negative 2 times negative 2 times negative 2 times negative 2. Well, negative 2 times negative 2 is a positive 4. Positive 4 times negative 2 is a negative 8. And then negative 8 times negative 2 is a positive 16. So we're going to get a positive 1 over 16 for example 1b. Let's look at example 1c. We've got negative 2 to the negative fifth power. So example 1c, we've got 2 to the negative fifth. So we're going to start by writing that as 1 over negative 2 to the positive 5. So let's expand that exponent out. We're going to have 1 over negative 2 times negative 2 times negative 2 times negative 2 times negative 2. Well, negative 2 times negative 2 times negative 2 times negative 2, 4 of them. We just figured out in example B makes 16. So positive 16 now times negative 2, that's going to make a negative 32. So our answer is going to be negative 1 over 32. And that's our answer for example 1c. 1d, 5 to the 0 power, well, a 0 exponent, our answer is always going to be 1. Plain and simple. If you have a base raised to the 0, as long as that base itself is not 0, your answer will be 1. Let's look at another example. Example 2. We're going to take and evaluate the expression a to the 0 times b to the negative 3 when a is 8 and b is negative 2. So let's plug in the numbers we know. We're going to have 8 to the power of 0 times negative 2 to the negative 3. Well, let's start with the easy thing. 8 to the 0, that's a 0 exponent. Anything raised to the 0 is going to give us a 1. Multiply. Now we can take care of that negative exponent. We're going to rewrite negative 2 to the negative third power as 1 over negative 2 to the positive third power. Now we can expand the exponent. We're going to have 1 times 1 over negative 2 times negative 2 times negative 2. Well, negative 2 times negative 2 is 4, and 4 times negative 2 is negative 8. So we're going to have 1 times negative 1 over 8. Well, anything times 1 is just itself, so we're going to end up with just negative 1/8. We're getting close. Let's look at another example, and then I've got some more exponent rules to give you. Here in example 3, all we're going to do is simplify the expression. And our expression is going to be x to the negative 3 over a to the 0, y to the 5th. All this means in the simplifying sense is we want to get rid of any negative exponents and any 0 exponents. So let's do that. We've got an a to the 0. We can just replace that with a 1. So we're going to have x to the negative 3 over 1 times y to the 5th. And anything times 1 is itself. So really we've got x to the negative 3 over y to the positive 5. We're not done yet because we still have this negative in our exponent. So what we're going to do is rewrite this as 1 over, and we're going to bring the x down into the denominator with the y. And then we can make that negative 3 a positive 3, and we can leave the y to the 5th where it is because it had no negative exponents and it was not raised to a 0. So that means our final answer is what we have right here. 1 over x to the 3rd, y to the 5th. Alright, so the next exponent now we're going to talk about, our exponent rule, is the multiplication or multiplying powers with the same base. Now to do this, all we're going to do is add the exponents. So, for example, let's say we have x and it's raised to the power of 2, and we're going to multiply that by x raised to the power of 4. Well, our answer, we're going to write it as x to the power of 2 plus 4, and 2 plus 4 is 6, so we write our final answer as x to the 6. Another exponent rule we need to know is, what do we do when we have a power of a power? What we're going to do is we're going to multiply the exponents. What does that mean? Well, if we had, say, x raised to the power of 3, and then we raise that expression to the power of 2, we're going to take and go x to the power of 3 times 2, and 3 times 2 is 6, so we're going to have x to the power of 6. And we've got one more exponent rule for us to know. What do we do when we divide powers with the same base? Well, all we're going to do is we're going to subtract the exponent. So let's say we have x to the power of 3, and that's being divided by x to the power of 5. We're going to write that as x to the power of 3 minus 5, and 3 minus 5, that's negative 2, so we're going to have x to the negative 2 power. And then we would go and take care of the negative exponent, just like we learned in the previous examples. So now to just generalize what we have here, if we have a base raised to the power of m, and we multiply it by the same base raised to another power, we'll call it n, it's going to equal that base raised to the sum of the powers. if we have a base raised to a power of m, and then we raise that expression to the power of n, we have that base to the power of m times n. If we have a base raised to the power of m over the same base to the n, we subtract m and n. Let's look at a couple examples and then we'll call it quits on this video. So our first example, or rather our fourth example, we're going to take 7 to the 5th, we'll call this 4a, 7 to the 5th, and we're going to multiply by 7 to the 8th, and we're going to multiply that by 7. So, what we're going to do is we're going to rewrite this as 7 to the power of 5 plus 8 plus, and technically that last 7 does have a power. That power is a 1. So we're going to have to also add 1. 5 plus 8 plus 1, that is equal to 13. So it is 7 to the 13th power. And if all they were asking us to do is simplify, we're done. If they asked us to evaluate, we would want to plug into our calculator 7 to the 13th power and figure out what that equals. Let's also look at, we'll call it 4b, where we've got 3x to the 5th times 12x to the 7th times x. Well, we can simply write it as 3 times 12 times x to the 5 plus 7 plus 1. 3 times 12 we know is 36. 5 plus 7 plus 1 is going to give us x to the power of 13. Let's look at a couple more examples. We'll look at for C, we're going to have 2 to the 5th power. We're going to raise that to the 3rd power. So we're going to have 2 to the power of 5 times 3. And 5 times 3 is 15, so we're going to have 2 to the 15th power. I think we can squeeze in at least 2 more, maybe a third additional example with this example 4. So example 4D, we're going to take 3z to the power of 2, and we're going to raise that expression to the 3rd power. Now this power of 3, that goes to both the 3 and a z to the 2. So we're going to rewrite this as 3 to the 3rd power times z to the power of 2 times 3. Well, 3 to the 3rd power, that's 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. So we're going to have 27 z, and 2 times 3 is 6. 27z to the power of 6. Let's look at 2 more. Let's look at what would we do if we have, here in E, 10 to the 8th power over 10 to the 5th power. Well, we're going to go and write that as 10 to the 8 minus 5. 8 minus 5 is 3, so we're going to have 10 to the 3rd power. And finally, we'll do one last one, example F. We're going to have 6 to the 2nd power times 6 to the 7th power divided by 6 to the 3rd power. So this combines 2 of the rules. We've got multiplying on the top, and then we have subtracting or dividing. So we're going to write it as 6 to the power of 2 plus 7 minus 3. 2 plus 7 is 9, and 9 minus 3 is 6. So we're going to have 6 to the 6th power. And that's going to wrap up our lesson on exponents.